So thank you very much for coming to today's webinar about artificial intelligence as it pertains to Java. We're going to cover quite a bit in the realm of how you can both use artificial intelligence for yourself, as well as integrate it into your applications to build things that you probably couldn't have built several years ago. We have quite a few panelists here, so we'll go around and let everyone introduce themselves.
Hi, everyone. My name is Svetlana. I'm leading evaluation team at JetBrains, and we are responsible for implementing and providing tools and different instruments to measure and track the quality of AI system features. I started at JetBrains as a Java developer, and I've been working in this industry for more than 10 years. And the last 4 years, I've been mostly focused on applying machine learning to improve development tools.
I'm Assis Savasing from Microsoft. At Microsoft, I'm on point for Java on Azure. Everything developers and customers need to build, modernize AI applications on Azure. I'm also a Java dev. I started in 1995 with JDK1, and I've been having a lot of fun with Java ever since. I've been at Microsoft for the past 20 years and been fully focused on Java, particularly making sure our customers have everything on Azure to build those applications. Very happy to be here today.
Hi, my name is Dov Katz. I'm with Morgan Stanley. I lead the Enterprise Application Infrastructure Group, and we're focused on developer experience and the core programming language stacks used by various production applications in the company. As I've been with Morgan Stanley for about 20 years, a little bit over that, and a bunch of technical and leadership roles. My hands-on programming started off, primarily in Java, so I've got a rich history, from building chat applications to trading systems to DevOps and everything in between. It's really great to be here today.
And lastly, I'm Jonathan Schneider. I'm a co-founder of Modern. Modern automates large-scale code changes that power strategic initiatives so developers can focus on feature development. About 10 years ago, as a member of Netflix Engineering Tools, I founded the Open Rewrite project, which provides rules-based refactoring, mass refactoring technology. Went on from Netflix to the Spring team, where I founded the Micrometer project. And so in some ways was part of the problem of making API changes that affected downstream developers that I'm now trying to help fix. A recent Java champion, and also very happy to be here.
All right, and I think I forgot to introduce myself. I'm Eric Kostel. I'm one of the editors on Java's InfoQ, or InfoQ's Java team. I also handle product management for Azul, for the Azul JVMs, running something called Intelligence Cloud that helps people identify unused code in their applications. All right, so to start things off, I'm going to say AI is generally considered a very new technology. So I think a lot of people are looking at it, but might not know when and where to use it. So when new tools appear, how do people figure out what they can use AI for and what the particular problem domains
are? Let me jump in, right? So the field of AI, the one that you just talked about, is very broad, right? Certainly, it's an exciting time here. And one of the coolest areas there are, like, you can use it for AI assisted development, right? Or AI infused applications, which we call as the intelligent apps. So intelligent apps are very interesting because they integrate AI to enhance the functionality and deliver amazing user experiences. For example, if you're using Azure OpenAI service as an example, you can use it in many ways, right? Some of the top use cases are you can use it for content generation. AI helps to create amazing blogs, articles, social media posts. You can use it for summarization. You can quickly, accurately summarize pretty long amount of information for you. Another exciting is the code gen. You can generate code where AI generates code snippets, automates many things. Additionally, the semantic search, it improves search results by understanding the context and the meaning of the queries, right? Now, there are some amazing, great examples. You're probably already seeing many of those if you're on LinkedIn. There are many, many posts by many of the consumers of AI. I'll quote a couple of examples, so you'll have some context. So if you take Mercedes-Benz, right? Everybody's familiar with the brand. It uses AI, and particularly on Azure to create some connected driven cars. They modernize their software development, which allow them to update and release very quickly. And it includes generative AI powered in car assistant that enhances you as the driver when you're driving. It enhances your experience, right? And there, the considerations were like connected products that they were able to continuously innovate, do real-time processing, and apply responsible AI as well, right? Another example I can quote is everybody knows American Airlines. They modernized their customer hub and they implemented that on Azure with OpenAI as well. They handle millions of real-time messages and service calls. Now, by using AI, they reduced the taxi times. They were able to save fuel and give passengers extra time to make their next flight. There, the key considerations were like transactions at scale, making sure they're able to comply with all the standards and distributed systems and AI for automating many, many things, right? So these examples show how AI is being used to create intelligent apps that drive amazing business outcomes and it improves end user. If you're the passenger, if you're the driver, it's exciting. So if you're a developer today, let me tell you, it's an exciting time to be involved in AI development.
So as developers, one of the things we're targeting for this particular panel is Java engineers who are building Java applications. We often have to approach, once we figure out what we're solving, we approach it from the context of grabbing a library, grabbing a particular piece of technology that we can use to play around with solutions for that piece of technology. So what are some of the key libraries that people can use and just tinker with to get started in AI development?
I've been very impressed with the breadth and documentation of LangChain4j, especially supports many different providers and seems to be very current with most of the more recent techniques like function calling that work their way into probably the more well-known LangChain Python library.
Yeah, LangChain is a very good example. If you are a Spring developer, you can also use Spring AI. They've also made it super easy, like almost like democratizing it so any app developer can jump in. If you're using Quarkus, Jakarta E, as Jonathan said, LangChain4j is amazing. Microsoft also has semantic kernel. It can help you in building amazing apps faster.
Yes, if you're a Java developer, don't despair. It's not just for Python folks. There's a lot of work that's been done to catch up and in some cases surpass, I think, what the underlying libraries really do in terms of quality and breadth.
Yeah, I tend to like Quarkus a lot, but I haven't experimented with any of the AI integration capabilities yet. And when it comes to integrating AI into applications or working with some of these new techniques, I find a lot of Java engineers, the applications have been around for quite a long time. So we tend to be working on some existing applications, and maybe people are struggling with maintenance of that because they've built up quite a few years of technical debt. So that maintenance of an application often takes up a lot of time that maybe we'd want to use for something cool like learning AI. So what can we talk about with a situation of how the Java engineers can really use artificial intelligence directly for themselves, not necessarily integrate it into the application for the user, but how can we benefit ourselves as Java engineers?
I think I'll start on this one as when it comes to migrations, as the founder of Open Rewrite, this is one of the key things that we've been working on. Development teams can't deliver enough software features because they're overworked by a never-ending list of technical debt and security findings that sap their limited capacity. I think interestingly, as we've started using AI in the net new code authorship, workflow, it's only accelerated this long-standing trend towards increased developer productivity and developing new code. Probably the most significant step function increase we've seen in that since the introduction of IDE rules-based refactors, 20-ish years ago. But now we've got just more code sitting on the shelf. I think we always see open rewrite recipes as this highly accurate cookie cutter that can, stamp out these low variability cookies. You need a system that is going to make the same kind of change in a provably accurate way across the hundreds of millions of lines of code that we've accrued over time. At one banking customer, we did a single Java 8 to 17 migration just on one repo, and it affected 19,000 files. Imagine each one of those files having the potential for a hallucination. So we focus our energy on how we can use AI to help generate net new recipes instead of using AI to directly make the change. In other words, AI isn't a cookie cutter itself. It's kind of the tool and die maker.
Okay, so for the things like porting from one XML library to another, since that was deprecated between Java 8 and Java 17, you have open rewrite recipes where artificial intelligence generated a series of step functions that people can use to do that automation and do that migration versus having to go through and do that manually as people.
That's right. Yeah, and then you want to deploy that at scale across tens of thousands of repositories to just eliminate that issue.
Okay, because I know it would take individual engineers quite a long time if we had to go into every file and change the imports, change the functions.
Yeah,
and
exactly. And it's boring.
Yeah, definitely not on the list of exciting things that we can do. Although maybe you get to do something else while the code is compiling. Dove, I know you did some of this work with maintenance using artificial intelligence. So how did you go about making the decision of whether to use AI to help do it or whether to allocate people to do it? And then what were some of your experiences using the large scale AI?
Sure. It's a great question. And so, back to the problem of the very boring 19,000 file change that needs to be made, there's also the error proneness to doing it inconsistently. That is another problem. And when looking at the book of work that your hygiene office wants to see done in your software estate over a given year, and you look at that versus the business features that they want you to implement, you start to say to yourself, we've got to find a better way to do this than go get a bunch of people focused on it inconsistently by hand and things like that. And I really broke the problem down into two kinds of problems, two categories. One of those is refactoring. Maybe that's upgrading dependencies. A lot of the open rewrite I put into the category of refactoring, although it's doing more than that, but it's trivializing the problem for a moment. And the other one is replatforming. So the code you want to keep, you tend to want to refactor. The code you don't want to keep, you tend to want to replatform. And replatforming could be anything from changing programming languages to gutting out an entire implementation of an enterprise application integration pattern, maybe moving from something proprietary to Spring integration or to Apache Camel. It's not quite as simple as an upgrade of a Java version. And for that, AI is great to get you on the right starting point. So what we've actually done is we've leveraged generative AI to help us understand what we were doing so that we can redo it a different way. So tell me what my requirements are from looking at my code and now implement those requirements in a different way is a great way to get started. But that compute doesn't scale to 19,000 files and so on and so forth. It's very expensive. So let's go back to the rewrite drawing board and figure out what we did. Can we create a deterministic, repeatable, scalable way of doing it? And now, I really have come to the conclusion that to solve this problem at scale, you need multiple tools in your tool chain. There isn't just one, and it isn't just going to get you 100% of the way there. You need to know how to combine the tools the right way. So one good example is really around that. It's around using generative AI to imagine things you want to do, and now go figure out how to do them at scale using some of the known and trusted ways of doing it. And that's made a huge difference. Looking at some of the things, I was just running some numbers yesterday based on like 15,000 code bases, trying to do that Java upgrade that Jonathan talked about. And it came out to about 50,000 hours of time saved, which is about 25 full-time consultants a year, just on a Java upgrade to 21, and that's the boring stuff. Imagine if there's other stuff I actually want to do, like use AI or any of that. I need to get on these modern Javas first. But then there's also a bunch of other frameworks I need to upgrade. There's legacy things that, and that's before we touch, I don't know, JavaScript and moving to new Angular and trying to get on new versions. CVEs are coming in and you got to respond quickly. There's a bunch of different motivations for why you'd want to change your code base. And you really, I believe people would want to be equipped with a combination of tools, know how to use them and when, in order to really tackle the problem at scale in a kind of cost-effective and accurate and predictable way.
Did you say you saved 50,000 hours?
50,000 hours. And millions of files changed. And, we were looking at the open rewrite approach. And the nice part about the recipes is you can ask them how much time they're saving. It's built into the recipe architecture. So it becomes very easy to make the case for how much time you're saving if it spits out, aggregate or aggregatable values at the end. So it's, that change this many files, change that many repos, and it's, this is how many hours you avoided. So even if it's off by a factor of 50%, I'm good. It's still more time than I want my developers who are highly talented spending on that problem. So I don't care if it's 90% inaccurate, I'm still fine. It's still time I don't want them spending.
Okay.
I think
one of the things that's really scary is just how broad these changes can be. We were looking at the Spring Boot 2 to 3 recipe that now has over 2,300 steps associated with it.
Wow.
Those are all the property changes and little idiosyncrasies. I'm sure we still don't cover it. That's the kind of load that we're putting, the cognitive load we're putting on a developer, on a kind of regular basis.
So,
Okay.
when I'm listening to hearing these numbers, what comes to my mind is GitHub Copilot, right? I know developers, they say they love it. One of the things that they're able to do is in situations like this, they can focus on what matters. Like go back to designing, brainstorming, collaborating, and planning. But much of these tasks like searching, documenting, finding problems, fixing it, upgrading it, writing tests, and you can also easily think like when Jonathan is talking about these recipes, open rewrite recipes particularly for developers who are focusing on upgrading Java, upgrading Spring Boot 2 to 3, Jakarta EE, or then they're continuously doing that you can easily see the Copilot come and help them over time by bringing together the recipes and the AI-assisted features into it. That way, it can help the developers can focus on getting these things done faster and then move on to adding intelligence to those applications.
So Svetlana, you've worked on some of these in JetBrains as well, some of the machine learning and AI assistant capabilities. What have you seen engineers using that for, and what are some of the AI capabilities that you've worked on?
A lot of different features. I mean, since IntelliJ is a product with a long history and with a wide variety of users, we actually did have a research and asked people what do they want to use, what do they want to do themselves, and what do they want to delegate to AI. And surprisingly, one of the most popular choices was that they want to delegate task generation and writing commit messages, documentation. And a lot of people actually didn't want to delegate writing code because that's part of their passion. That's what they want to do.
That sounds right.
So what is there in the way of AI commit messages? Like you can just automatically summarize a commit and write a nice message for it?
Yes, yeah, why not? I mean, it still doesn't get information from your head. It's still, if you want to add information, not only what was changed, but why it was changed. In this case, you'll probably need additional context, like the issue itself. I would say that's work in progress, but that's where all AI tools are going to be in the nearest future. I mean, we're adding more and more information to different technologies, and they are able to summarize them in the best possible way.
In terms of test generation, is there some kind of reward system based on code coverage?
Do you mean reward for
Just
AI
something
or for
where,
developers?
well, yeah. So AI generating tests for me is definitely a reward system for me. Sorry, no, I was thinking in the way of the AI figuring out how to write the test so that it covers more of the code.
There is an approach. We're currently investigating that. We're not using it in production yet, but yeah, we are checking how can we do that, how can we apply that information. So first of all, to measure the quality, because I mean it is a tricky part, since with AI, with generating code, you can't just compare expected result with an actual output, because there are so many different ways to solve the same problem. So one has to go a bit in a different direction and actually try to either execute code or write tests and execute them, or compute some other, I'll say, meta information about the code, if it's syntactically correct, how many methods does it generate, if we want to have something simpler or not. And test coverage is definitely one of them.
Okay. So yeah, in the case of things like a large scale code refactor, how well does the code need to be tested? Because I talk to people on a regular basis, and they might be, there's always a goal of having 100%, but nobody ever hits that. So there's a goal of having 90%. People generally don't hit that either, but we have like a moderate level of testing. So if you do a large scale code refactor, what do you need in terms of tests to be confident of that end result? And do you refactor the tests as well?
So I've talked to many Java developers and customers on this particular one, right? When they first start, typically if it is a production system, let's say it's an inventory system or a stock trading system, they already have a set of tests, right? Whether they are running the test in a retail unit, in a store, or in a warehouse, or in a truck where things are going. So they have all those tests. So all those tests are pretty important as they move forward, right? They go through the refactoring, whether they are upgrading using the open rewrite recipes that Jonathan talked about, whether they are breaking them down from monolith into microservices, making it easy to scale in the cloud, things. Let's say they break all down. When they bring them all together, still those test cases are very important. Now, when it comes to code level unit testing, that is where things change, right? They have to now generate new test cases based on the new code. But when it comes to functionality, integration, compliance, all those test cases, they're all staying intact, and they have to go through all those testing before they switch from one production to another new production.
I think that's also a question: what do you consider a final artifact of your work? And one may consider that it is a code which actually functions and do the thing that it's supposed to do. But one can always also think about tests as part of this artifact, because that's also kind of documentation which you don't need to update on a regular basis. Because everyone have read that documentation which was true like a year ago, but it's not anymore.
Right.
There's one other element to this question, I think, about gaining confidence in a large scale refactor. One thing I think we haven't mentioned is that when an open rewrite recipe is running, it's based on a data structure called the lossless semantic tree. So it's not just the text of the code, but also everything the compiler knows, the resolved dependencies. Very similar to what's in the IDE. When the IDE does an indexing operation, it knows more about the code than is just visible in the text. And some of the properties we've been adding to the LST are things like, is the statement covered or not? And more recently, working with Azul, it's been, is the statement reachable or not? And so a statement that's reachable has a higher risk score for a refactoring operation than one that isn't. A statement that's covered already has a lower risk score than one that is not. And so you can do a large scale refactoring over a code base and actually calculate a risk score based on the combination of those factors. Is it reachable? Is it covered? And then prioritize maybe merging those repositories that have the lowest risk scores and focusing your manual review effort on the ones that have the highest ones. I don't think we'll ever get to a place where we have the same degree of confidence, kind of uniformly across the whole enterprise.
All right, and we have a question in here. So anyone who does have a question, you can feel free to write it into the question and answer area. Is it possible to modularize code, componentize, and even name the modules? So to take something that's large and break it down, use AI to figure out where the cut points are so that you can break it into smaller pieces or modules.
If it's about naming, I hope we train those AIs on Spring's naming conventions, right? That's famous, right? Those are really, really long.
Yes, and abstract everything.
That's right.
Okay, but Oscar, you indicated that you could break something down in terms of identifying different functions to where you could modularize things to a degree.
Yeah, I think that's true. Whether it's naming or modularization, right? If you're using something like, I'll quote an example as GitHub Copilot, right? It knows your organization code base, right? That way, if you are a developer, it helps you onboard quickly, and then it offers suggestions based on your own internal and private code, right? This way, you know the direction and it'll break it down. Now, as you move towards like working in a collaborative environment, right, it also helps them stay in focus by helping them collaborate more effectively, whether it's reviewing pull requests or generating amazing summaries so others can understand what you did. And that way it makes it easier to manage the projects and maintain a good quality code. You can also, like one of the things that Svetlana mentioned is they may have written the documentation 10 years ago, but the code base is changing. So the Copilot can assist you with building that new documentation, right? So it can come up with these suggestions, whether it's names or modularization or upgrades, right? Or whether it's collaboration, all of those things will help you. And the goal with all those help is it makes you super productive in achieving your backlog so you can get to the plane where you are actually going to add AI infused intelligence into your apps so that you can generate even more business outcome and deliver amazing end user experiences.
All right, and we have another question here. I think this is particularly interesting because a lot of engineers, we want to move forward, but we do tend to have these large scale backlogs. So maybe we can't do that future thing that we want. So one of the questions here is, can AI help us understand legacy code by generating documentation? And do we have any tools that are geared towards documenting those materials?
Sure, I think that generation documentation is one of the standard things to have on different AI systems. It is included in AI systems from JetBrains. I'm sure it is included in others, and
Yep.
Yeah, it's one of the things that people want to delegate to AI, and it makes completely sense.
Just back to the comment I made earlier, I think there's definitely this view that you can back into requirements when you give AI some code. And that has been a very effective means for a bunch of replatforming that we've done, experimenting with kind of approved connections to generative AI. Here is chunks of the project at a time, because obviously you're dealing with tokens and all the compute boundaries that tend to limit what you can do. But you start to go in that direction, and you're reverse engineering for the sake of forward engineering afterwards. And that's extremely powerful. Just saying, what does this thing do? Go do it in Python. Like, it's a Perl to Python play, where it may not just be convert every method to an equivalent method. It's like, just do this thing better in a different language. And that's not always a refactor. That's why you got to back into some English language requirements, maybe. That's definitely been an effective way for us to experiment with some of these approaches.
Okay. Yeah, every couple of years I see a new COBOL to Java translator come up to play. So I don't think we've done that with AI just yet. But that is definitely a thing that I, as a human, would not want to do.
I love that so far in the space of this roundtable, we've now discussed AI replacing naming, testing, and documentation. Probably three favorite developer tasks, right?
Yeah, take all the stuff that you don't want to do and then make AI do it. So that's kind of the outcome of this webinar is like, don't do the stuff that you don't enjoy anymore. Make AI do that. That might be, everybody likes to make Terminator jokes. So maybe that's the reason is they
That's
said,
right.
I don't want to do naming anymore. And
That's
that
right.
caused.
And migrations. Yeah.
Yes.
We've definitely found some other, sorry, go ahead.
Yeah, then maybe AI don't want to do that either, and it will make us to do it again.
It'll get bored.
Is that a product announcement, Svetlana, or?
We'll see.
Yeah, I was just going to mention there's definitely this use case that goes beyond those perhaps less interesting tasks that we want to avoid doing, where we found other use cases that I thought would be worth mentioning. For example, if you have an architecture discipline and you're writing ADRs, architecture decision records, and you'd like someone to make sure those are actually following your architecture principles and stuff like that, you want to start getting into what would architects do in terms of giving you feedback. Pull requests, and I know in the GitHub ecosystem, I'm expecting a lot there, right? Pull request reviews. Usually in the concept, you have like a first line review, a second line review, and that. AI should just be the first line review. Like you should be reviewing AI reviewed code. There's no reason to look at a pull request review that AI didn't already review in the future. So, I don't want to waste my time on it if it's obvious stuff. Those are great opportunities to employ AI kind of in the SDLC, if you will, to give you a higher confidence level that it's worth your time, right? So there's definitely just great use cases throughout the rest of the SDLC worth pointing out.
Okay, yeah, because I've always done a lot with the realm of code quality checkers, like you've got PMD, you've got find bugs, you've got a variety of those, and people are expected to run them. But then you commit that code. So what you're saying is AI reviews the code and provides context more akin to what a human would in terms of whether or not that meets the enterprise scope.
Just give me feedback. Like, just like if I asked you to write the code, you would have written it for me as AI. Give me feedback now that I chose to write the code. As Svetlana said, like, we want to write the code. Give me the feedback on the code I wrote since I'm not letting you write it, right? And then I'm sure there's what to say. There's probably good suggestions there. And, sometimes there's a set of standards. Yeah, you want your department to follow a set of standards. You're not following them. AI calls you out on it. Not everything can be written down in a kind of a fitness test that you can run. So this might provide you with a bit more of a qualitative review. There's just these opportunities, I think, that could be leveraged, and I'm sure we're going to see them in the products space that developers are typically using.
I remember a principal engineer telling me once, he said, I feel like I'm going around telling my kids to pick up their socks all the time. And I'm like, yes, I feel that, right? Like, I mean, the moment you kind of get everybody where you want them, like reorg or new product team comes in or something, and we need to make them feel like they're creating, not picking up, teaching stock pickup or whatever is, whatever you call that.
So when Doe was talking about the pull requests reviewed by AI, I think the important thing there is when it's reviewing pull requests or writing those summaries, right? When the AI knows your organization's code base, right? And it knows whatever standards that you are implementing, then it makes it super easy, right? And developers can even run those offline before they even open the pull request. So the AI can say, hey, I've reviewed it, everything looks cool. And then the developers can come in and look at the review as the second or the third reviewer.
Got it. Yes. So it becomes the reviewer in the pipeline versus just the generator of code that then humans review.
Right.
You can also go further and ask AI to generate tests, then ask AI to generate code, which will pause those tests, then generate tests, which will actually fail the code that is just written and go in this loop and trying to find the results that we have. And I have seen that a lot of, I'm not sure tools, but a lot of research are working in this direction. Now, I'm sure that we'll see interesting results in the nearest future.
All right, Jonathan, we had another question come in that's about open rewrite, so I'll direct it towards you. It says, one challenge I've noticed during the spring upgrade is managing shared libraries across different projects. Is Open Rewrite the right solution for upgrading these shared libraries, or should we consider using AI to ensure that the updates don't break APIs and applications?
So there is definitely still a sequencing problem when you have shared libraries, right? That you have to merge those first and then move forward. I think that's where Open Rewrite used, I think, on one repository at a time gets difficult. And that's kind of what we've been doing as Modern, kind of like allowing a recipe to run on a whole organization, like a whole business unit. It usually starts actually with an impact analysis, like a a recipe that just it says like this is the sequence or order of dependencies between projects, the merge order essentially. Then you're running the recipe according to that order, and then merging them accordingly. So it can be easy, I think, when you're running a recipe on one repo to kind of just miss the forest for the trees, so to speak. But that's definitely a problem. Going back to Netflix, this is sort of related. Many years ago, that engineering org almost ground to a halt because of Google Guava, the famous Guava. That there was a common libraries that used it and applications used it, and neither could move because they might break the other. And which could you move first? You can't move the library first or it breaks the app. You can't move the app first or it breaks the library. And so we actually built a series of recipes that eliminated just the API surface area that changed between these disparate versions, so that it didn't matter which. We effectively broke the link. Then you could move the library first, or you could move the app first, and then once it started going, then everybody can move forward. But it's interesting that one library almost like killed all forward progress just because of how many libraries had transitive dependencies on it.
One thing to add to that, Jonathan, I think as you look at taking a large organization like a list of repositories and try to find a sequencing solution, is with the focus these days on the software supply chain and SBOMs and all those other bill of materials type products or kind of files and formats, a company which manages to ingest a large number of repositories of its own probably knows the interrelationship between them to the point of being able to determine the tree. And then you can figure out, back to the question that was asked, what is the right sequence of the shared
That's
libraries? Right. A clever way to break the linkage is also, very, very much, of value, but at least benefit from that institutional knowledge in a way that we can find the right order and roll things out in a kind of least impactful, least damaging way.
Right.
All right. So I want to move forward a little bit. We talked a lot about updating code of how people can use AI on their own. And now I want to talk a little bit about integrating AI services, or now that you've solved your maintenance problem and you have more free time to be able to focus on cool business features and things that can enhance what you're doing, how can you take advantage of AI to do a little bit more? So Svetlana, the product you worked on is a little unique because it uses AI on the back end. But the thing that you make available is actually AI to the engineers. So can you talk a little bit about how integrating AI into your application works? Like what's local on the machine, what still needs a backend service? What should we know about putting AI into applications?
So first of all, AI is very polarizing topic, and a lot of people are eager to try it and see what it's capable of. And on the other hand, there are a lot of people who are trying to avoid it and wouldn't want to use any AI first or any product with a lot of AI integrated. So, I mean, both of these points make sense. AI does blur this line between code ownership, who's actually a person who is actually a company or person who owns the final artifact of your work. But what's crucial is to know your audience, as to understand who are you aiming to, and if these people actually will be happy to try it, or they will be disappointed that AI will basically developing all things that they used to do will be less fun and less enjoyable because part of that will be delegated to AI. So, and in case of IntelliJ, I mean, it is a huge product with a lot of different customers. So we had to actually go in different directions here. So for customers who value privacy the most and who don't want to, or their employees don't allow them to do it, to send code to third-party servers, we do have completely local solutions. And that part it's tricky. I mean, you have to think about model size, you have to think about consumed memory. And at least right now, it might be changing in the future, but at least at this point, it's not possible to have general purpose AI, which can do like, state-of-the-art things, which you can do, let's say, with ChatGPT. It's just local machines and local laptops are not there yet. I mean, usually. So, but what is possible to do is to change the scope of the task to make it smaller and to make your model to solve one particular task or maybe a couple of them. And in this case, it's completely doable to train something from scratch or tune open source model, and it will be on par with another implementation, server-based implementation. So at this point, we have two major features delivered that way. And we have a full-line code completion, which is also available in Java, and it's actually included at JetBrains product. There is no additional running cost for us because I mean it's already happening on the machine, so it is included in regular subscription. One doesn't have to pay any extra cost to have that feature. And the second one is semantic search integrated in Search Everywhere. It is based on embeddings and it's also completely local solution. Yeah, on the other hand, it's still not possible to have everything this locally, or at least one has to do a lot of additional work on top of that to get there. So we're also exploring server-based applications. And in this case, we would want to move as much logic as possible to the server, because I mean, it will make it easier for us to iterate and update this logic and change models or model providers. It's not possible to make the client completely thin, because we still have all of that context, and context is what makes actual difference between regular and using AI as is, just with changing prompt and making something which is adapted for a particular person, for a particular project. So as of now, this differentiation comes to everything which is about a particular person who's working with AI happens inside IDE, and things that can be shared between multiple users, it usually happens on the server. So for instance, UI and UX, it's obviously on IDE part, but also gathering this context, which parts are relevant, technologies used or languages or methods which are relevant to selected code fragment or natural language query and so on. That stuff happens on site IDE. There is also a post-processor stage. How do we apply the code which was generated to an open file? It's also inside IDE. And on the server side, we do have more integration with language model providers. We are selecting proper models and prompts. We are hosting model inference for in-house models. There's a lot of business logic on top of that. There are indexes for documentations that we have and that we want to make accessible from an IDE.
Awesome. All right. So, Asser, you're providing a lot of AI services, like Azure has a lot of things on the back end for people to use in their applications. So for a lot of Java engineers, we do things in Java. We tend to learn things that are tangential to them. But about how much information does somebody need to know about artificial intelligence, and how much can they focus on using the library or the service?
So how much do they need to know, right? That's a very important thing. I will start by saying that if you're a developer, you can start today. That's very important. You can start today, right? So every app will be reinvented with AI. There'll be new apps built that were not possible before. So the opportunities are super high, right? So when we talk about you can start today, right, there are different personas playing a role here. Different people, they play a critical role in building these intelligent applications. I have three: AI engineers, data engineers, and app developers. I'll say a few words about this and then go into a focused area here. So AI engineers, they focus on developing and deploying AI models, right? Data engineers, they manage and process data, with data scientists and machine learning engineers playing pretty critical roles. Data scientists, they explore data, discover insights, build the model, prototypes. Machine learning engineers, they train, fine-tune, deploy models, ensuring that they are ready for production, right? So you have these AI engineers and the data engineers. However, the spotlight is actually on app developers, because our organizations, customer organizations, they need a lot of app developers to infuse this intelligence. So app developers, they integrate AI into applications to create these amazing intelligence solutions. They build all the user interfaces, application logic, and they leverage the AI models, right? This ensures that the AI capabilities are seamlessly integrated, providing a smooth and intuitive, amazing end user experiences. Now, what happens in this case is three things are coming together when these three personas play a role, right? So there's an app platform where you're deploying the apps, there's data platform where the data is brought in together, and then there's the AI services. So the three things come together, right? So if you are a Java developer, you can start today. And if you're a Java developer, then this is the best time for you, because lots of enterprise applications are in Java and you can start today. You can start today, integrate into your apps. So I want to re-echo what we started early this morning as well. If you're a Spring developer, you can use Spring AI. They made it super easy. If you are using Quarkus, Jakarta E, and other system, you can use LangChain4j, right? And Microsoft also has semantic kernel to assist you in building these applications. So the key thing is you can start today and you can work with different personas and move things forward as fast as you can.
I do have a couple more tips for those who do want to integrate AI into their applications. I mean, there are different things to keep in mind, but from my point of view, there are like two major ones which actually makes a difference. Because there's a blessing and a curse of working with large language models, that you can very easy to get to a working prototype. You can just spend a couple of hours and you already have something impressive. You can already show a demo and get everyone excited. But the next part is actually going from a demo to production level quality is a very complicated one, and a lot of products don't make it. And to be honest, that part is actually hard to predict. Sometimes it's hard to say how difficult that is, how much time we'll get, and if it's actually possible to reach a proper level. And what helps here is thinking into creating a kind of a data-driven loop around your feature from the very beginning. So it's kind of like a test-driven development, where when you start working on functionality, you think about how should it look like, what should be expected input and output. And I mean, in this case, we don't expect that all of the tests will pass. It is fine. I mean, it will be always the case. If not everything will succeed, and that's all right. But it allows you to actually measure. And if you want to fix one problem and you tune a prompt and you fix it, you're making sure that you're not breaking several other things along the way. Because with using a prompt, sometimes you can just change a double quote to a single quote, and it will blow your application, and it will change formatting and everything it returns. So it is important to track it and to make sure that your consecutive step doesn't make it worse in an unexpected way. And it will also allow you to try different models, because in AI, a lot of stuff happening very fast, and new models arrive, but also old models are getting deprecated with pretty short notice. So it is, one can't stuck with one model and say that it is enough and have to update to a newer version. And if it's easy to do, if that process is semi-automated, it's not that complicated. It's you don't have to spend a lot of hours doing it. And the second part, which I would say is very, very important, is to user experience and how do you present those results. Because as I've said, you can't achieve 100% accuracy, and that's all right, as long as it is built in your overall user experience. Have to set expectations right. So a person who will be using your application don't expect that these suggestions will be always perfect, but it should be also possible to tweak them or maybe reject the suggestion. It shouldn't be forced to a user. It should be easy to, more like a guidance, not something which forces a process.
All right. I think Dove might have frozen there, but that's okay. So how do you keep up to date with the different models that you have? Like you said, some of the models go out of date.
Yeah, I mean, we do have a couple of our in-house models, but for most of the functionality, especially state-of-the-art part with the chat, we are using external large language model providers like OpenAI or Google Cloud. And in this case, they do release new models, but they also deprecate older ones. So what we have here is that we do have a process to evaluate new models. So when something new arrives, we can check it against our benchmarks and see how it works in terms of metrics, but also what are potential problems that we get. Maybe some of the functions worked well with the previous version of the model, but it doesn't work that way with a newer one.
Right. And as a Java engineer or somebody who's working on an application like us, or you were talking about the key time to be an app developer, how do you look at and evaluate which models you're going to pick to solve something? Like what goes into that?
So this is where your AI engineers can help you, right? They can you have to start from your business requirements, figuring out what you're trying to solve, right? Come up with those requirements, and then go into kind of like an ideation phase to figure out which model can help you. So in the Azure space, we have this AI Studio, right? Within the AI Studio, you can try out models. You can run your ideation workshop with your fellow engineers or with your user base as well, right? Start experimenting which ones will help you. Whether you're going to use one of the pre-built models or you're going to fine-tune them, right? And if you're fine-tuning where the data comes, so you can do all those ideation, experimentation, figure out what works before you bring it into the application itself. So when you finally bring into the application, then the focus will be on what is the end user experience and how you deliver that. So for example, if you're building a retail store, your key concept there will be to how to fill the cart and how to help them place the order, or how to augment the cart, like add more items into the cart. How do you use the model and how do you build that experience so that you can help them fill, augment the cart, and then close the cart? Because sometimes, those end customers will jump out of your application and look somewhere else. The moment they look somewhere else, they probably go into another store online, right? So how do you build those experiences in a way that you can retain the engagement of the customer and end customers? So that's where you go back to your Azure AI Studio. You have all the models, access to all the models that are available there. New models are coming through. So you can run your ideation workshops, start experimenting with your end users as well. And then you can bring those experiences into the applications and deliver them to your end customers.
Okay, so using your cart example, I could run simulations of carts through it and look at what the suggestions it had were, and that's how I would pick which of the models that I wanted
Exactly.
was based on the one that gave me the best results.
Correct.
Or
It also goes back to your business requirements, right? Your requirements should be like how many items you're able to add more, how many of those customers, like 100 customers coming through the process, did 90 of them place the order, 80 of them place the order? Like you can come from that and reverse engineer and then pick the right models from here.
Okay, so I have a set of success criteria of I need to increase my number of conversions. So let me pick an
Exactly.
AI model that for the time being increases those conversions. Then when
Correct.
I have conversions, I figure out how can I add more things to the cart. So which of these AI models helps me get more things
Correct.
into the cart. And then I
Correct.
can build my application with like the Azure AI Studio and things like LangChain for J.
Right. So nothing has changed in this process, right? You always starts with your outcome, your requirements, use cases, and then pick the technology because
Right.
companies like Microsoft will give you a plethora of technologies. It's not like you have to use all of them. You have to pick what meets your requirements, what takes you to success, what helps you make more money.
There's one other characteristic I've noticed when selecting models, and that's that we generally don't just select one model for an experience, but often wind up selecting multiple and developing a pipeline by which we use small models to limit the search space and therefore the compute required. So as an example, we developed a feature, I suppose, to do recommendations for which recipe to run on a code base. If I just give every next 10 lines of code to a model and say, what do I do here? What do I do here? What do I do here? We had done this study. What if we did this for an average size generative model and it implied 75 years of total induced latency? So it's like, for the average size business unit. So how do we limit the search space so we don't have to send every fragment of this code base to this model? So instead, we developed a pipeline where first we just take every method declaration, embed them, cluster them, and then select samples from the cluster so that we're not asking effectively the same question over and over again for highly similar methods. Those embedding models are much, much, much cheaper, much smaller, oftentimes 1 to 2 gigs of RAM. You can run them locally, you can run them at zero marginal cost, and then reserve the more sophisticated model for the generative part later on. And I think that's the way, Svetlana was mentioning that earlier, like you can really choose small models that are good at individual small tasks, and then just reserve the kind of like big guns for the later stage somewhere down after you've narrowly filtered the search space. Wrote a whole book actually on this recently, just a short 35-page book. It's free from O'Reilly called AI for Mass Scale Code Refactoring and Analysis, where we describe in great depth like how we select those models, how you deploy them, how you evaluate them, and hope that's helpful to folks to look at.
Outstanding. So I think we could take a look at that book and quite a few other things. We are at about 9:58 now, so we're coming up on time. So I just wanted to say thank you very much to everyone for attending. We have a question that came in. Can we reverse engineer from code to use cases? Yes, we talked about that quite a bit in the past about automated code refactoring at scale. So yes, you can do that. Covered it quite a bit. So just thank you very much for everyone for attending. We will be publishing this webinar. I think if you're subscribed, you'll get it within about 48 hours. It'll go live to it'll go as a recording to other people a little bit beyond that. And in the future, we'll just publish a lot more developer and AI news articles on InfoQ, bring a lot more experts into events such as QCon. So I'd like to thank all of the panelists for attending today and providing their expertise. And if anyone would like to follow up with anyone, just feel free to use networks. You've got LinkedIn, you've got Discord, and quite a few other social networks. So feel absolutely welcome to stay in touch. And thank you very much, everyone.
Thank you.
Thanks for having us.
Thank you.